when we get something that looks like this. This one we want to show that the limit does not exist. Okay, so you can see the notation, the new notation, the limit as x approaches 0. I'm just going to shrink this graph. As x approaches 0, of this function, and so we have the absolute value of x over x. And so I'm actually going to graph it on my graphing calculator. You could graph it by hand if you want. It doesn't really matter, but we're going to graph it on our graphing calculator to see what it looks like. And so just so we can see what's happening as x approaches 0. And it's always a good idea to do this, to graph it, just to see, because I mean, I don't know about you, but I'm not used to seeing this function very often. And so when I graph it, I get something that looks like this. All right, well, let me zoom it, make this graph a little bit bigger, and there's my graph as x approaches for the absolute value of x over x. Well, as I get this, and you could have plotted points and you would have gotten the same thing, and that's just, I was just saving a little bit of time. But you can see that for this, if I want to approach 0, well, here's x equals 0 right along this line right here. X approaches 0. Well, what happens as I approach from the positive side? From the positive side, it looks like I'm approaching 1. Well, from the negative side over here, it looks like I'm approaching -1. Are these two values the same? 1 and -1. Well, the answer is no. When they are not the same, the limit does not exist. And you can just use D&E. Doesn't exist. It has to approach the same value from both sides for the limit to exist. That's really all there is to this one. This is one way limits do not exist. Not approaching the same number. Not approaching the same y value. Okay, when they don't approach the same y value, it's a does not exist. Okay, does not exist, 1, when not approaching the same y value. That is something that is very important. Remember that. Okay, and you can see this is what they're talking about down here. And I'll show it to you so you can look at it. But this is all delta stuff. You don't really need to worry about it. So we're going to move along. And so then another one that says discuss the existence of a limit. Well, I'm going to get rid of this graph again because I'll just graph it on my graphing calculator. But we're going to approach 0. So if I go ahead and graph this one, and because I'm graphing it because I don't necessarily know what this one looks like every time. And so if I graph it as I approach 0, look at my graph. Let me zoom in on this graph. Well, what's happening? As I approach 0, as I get closer and closer to 0 in the x values from the positive side, the graph looks like it shoots up to infinity. Well, this is where we have to have a discussion about what infinity is. On the other side, as I approach x from the negative side, so as I get closer to 0 from the negative side, I also approaches infinity. Well, the question is this: is infinity a number? And that answer is no. Infinity is actually a concept, and the concept of infinity is the biggest thing you can ever think of. Because how I always think about this, that infinity is not a number, is count the numbers from 1 to infinity. Well, if you count the numbers from 1 to infinity, you end up you get way up to infinity. It's a huge number, and then I say, okay, well, let's do this. Let's count by 2s until we get to infinity. Well, is the group of counting by 1s to infinity bigger or smaller than the group of counting by 2s to infinity? So if you think about that, infinity is just a concept. It's not really a number. So we're not really approaching any value. So again, this one is a does not exist. Because we want to know what happens when the limit of what y value is it approaching. Since it approaches infinity, so the second one here does not exist when the graph y values approach infinity. Now, what happens if this graph was flipped upside down? Well, the only difference is that kind of messes up my little arrows there, but the only difference is when I flip it upside down is the fact that the graph still doesn't. They're approaching negative infinity, and that's really the only change to that one, is that those are approaching negative infinity, but it still falls into it approaching infinity, and therefore it does not exist. And then the last one is, well, what happens if we approach, if my graph, let me flip the graph back over. What happens if my graph would have originally been not both going up or both going down? What happens, the only other option is, what if one goes up and one goes down? And so say like this guy over here wasn't going up, it was doing this. It kind of goes back to the first category, is as we approach the graph from the negative side, the graph is going to negative infinity. And as we approach the graph from the positive side, we're approaching positive infinity. And in the previous example, I said if they approach two different numbers, the limit doesn't exist. So that's what we're talking about. Remember, limits are asking you, what is the y value when x gets really close to this value up here that I just put in the box? So that's what limits are all about. And so this is the solution to that. And it basically goes through, and I'll slide it down far enough so you can see what they talk about. And then you can pause it if you need to get any of it down. But that's basically the same idea. I didn't use all the numbers that they did, but that's the same idea. And so then the next one, I think this is the last one that we're going to talk about, is what happens if we get a graph that looks like this. So best way to do this one, and I wouldn't even suggest plotting this one by hand, I would suggest graphing it. If I go ahead and graph this and I say 1 divided by x, and I graph it, it would help if I was in radian mode. Make sure you're in radian mode, not degrees. Right, so if I graph it, I get something that looks like this. Well, there's the first zoom in. Okay, it looks something like that. You can't really see what's going on. So I'm going to go back and I'm going to try this again. I'm going to zoom in. And if I zoom in on this one, let's just do zoom trig, just because that would be a little bit better, but it's not much better. It looks something like this, and so I'm going to make it a little bit bigger. You can see, still don't know exactly what's happening as I get close to 0. So let's zoom in on it one more time. This time I'm just going to do a zoom in, and hopefully it's right around 0. You can see, oh boy, look what's happening there. And so you can see the graph itself is still having all kinds of crazy things happening on as I get close to 0. I'm going to zoom in one more time. Zoom in one more time. And you can't even see what's happening, so the graph got so big that part of it's out of the screen. But you can see we can't tell what's happening at 0, because all this graph just keeps getting closer and closer, but keeps jumping up and down. And what it really jumps up and down to is, because it's sine, hopefully you remember that it jumps up to 1, down to -1, up to 1, down to -1. And this is what we call an oscillating graph. So the third way it does not exist, this limit does not exist, because the graph is oscillating. Graph oscillates. Oscillates. When the graph oscillates from one number to another, the limit does not exist. And so that's really what we're talking about. So there are 3 ways limits do not exist. And this is what they're talking about, and that you can go through and see the solution. And they did all the graph, and they plotted points, and you can see how it jumps from positive to negative. And so pause it if you want to look at it and read it a little further. But the 3 common ways that a graph does not exist. So back to our very first example. The point was not there, but we approached the same number from both sides. That one worked. The second one, the point was there but not on the graph itself, but the graph still approached the same number. The y values were the same as we approached the x value. So that was the second way that worked. And then these are the 3 ways it doesn't work. So this was the example. Approach a different number from the left and from the right. That was one. That was the first one I told you. The second one, increase or decrease without bound as we approach it. That was the infinity one. This was infinity. And the final one, and I think this one up here was example 3, I believe. This one was example 4. And the last one oscillates between two fixed values, like from -1, +1, -1, +1, and that was example 5. And so this is the summary of the whole section. Make sure that you really understand this, and please be prepared to work on the homework. Thank you very much. Hope you enjoyed the first webinar.